Right. Welcome, everybody. Thanks for tuning in for PyChain today. And our next speaker, Ben, he's been working with IT for a long, long time, and he's going to share more about his experience with Vyper today. So, Ben, take it away.
All right, thanks very much. I like submitted 4 different talks in various technical things or whatever, and of all the talks they selected was this generic one where basically I rant a lot about crypto ledgers and how I discovered Vyper. So I know Patrick and Garrett were both talking about Vyper and Solidity earlier on, and both of them had some affinity for Solidity and didn't want to say anything bad about it. If that disappointed you, then this might be the talk for you, because I will be highly opinionated. I am a systems curmudgeon because I've been programming seriously commercially since 1983. I focus on system architecture and language design. I've been heavily involved with cryptography since 1991 in the security industry. And so we're going to try to cover in this short time 5 different topics, right? First is just the architectural drivers of crypto ledger contracts. I like to use the word crypto ledger because it's more precise than blockchain. A blockchain is one way of implementing a crypto ledger, but crypto ledger has all the aspects of what crypto is supposed to provide. It's a more correct definition, and that word ledger is very important. Secondly, why programming languages matter, and they matter a lot, and why it matters what kind of language you use and what languages are appropriate using the right tool for the job. Thirdly is why Solidity has been a costly mistake that we continue to pay for. 4 is how I discovered and used Vyper, and 5, why you should use Vyper and what you have to look forward to once you start adopting it and going forward. So right on. So crypto ledgers as the platform, right? We use the word smart contracts. They are not smart. They're the stupidest contracts in the world. They're the most basic, primitive, nonsensical things in the world. And there's nothing smart about them. It is cool. You have code and algorithms executing directly on the ledger on a decentralized ledger. That's pretty awesome stuff. This is going to be world changing. It's going to replace World Wide Web as the #1 protocol. I love how I don't know who did it, but whoever came up with the marketing term Web3, heck of a job, right? Good going. Contract, right? Civil agreements and legal structures as code. Well, okay, automated enforcement is cool. But we also introduce execution of the contract. So in human terms, in business and civil case law, contracts only specify what is possible. They do not specify how to do it. And they do not cause the thing to happen. Your lawyers don't make anything go for you. They just tell you what you can or can't do and have it adjudicated when something goes wrong. Basically, exception handling. And you'll notice that 90% of the code that you write 90% of what you write in a contract is exception handling in the real world. We can think of protocols as jurisdictions. And this will not only change our economy, but also completely how we govern ourselves. Thirdly, this whole thing is built on a foundation of sand, costing us billions of dollars a year in losses. So we're doing this stuff that's going to change the world, and our grandkids are going to ask us, what? You really built smart contracts? You really built, these decentralized systems back then with this kind of primitive tools and, didn't get slammed? Well, no, we did get slammed, right? We're being slammed now. So how do we get here, right? Well, most of these slides I actually created in 2018 for a talk for FOSS Asia in Singapore. I'm coming at you right now from Bangkok, and it's like 10:45. Or 10:54 now. So when I was preparing that, I was looking for some research, and this great tweet came by from this physicist. He says, "I didn't come up in computer science. I used to be a physicist. That transition gave me a rather specific perspective on the situation. That computer science is a field which hasn't yet encountered consequences." That is so profound. For one thing, let me tell you, no term that has the word science in it is a legitimate science. Physics, chemistry, biology, those are legitimate sciences. Political science, computer science, they are not sciences. We are not there. We have massive hubris to believe that, right? We have problems that people are building things, our computer sciences, our programmers, that we don't have any skin in the game. We do not take the loss if the thing blows up. We're just seeing that recently, right? In a big, big way. And it's got introduced some very serious ethical issues. And we have to get our house in order before someone else does. Legislatures are going to come down on us, and certification is not the answer. All this was written in 2018, still true today. So we got Ethereum, right? So what am I talking about on consequences? Who can guess, right? 1 year after ERC-20 was released, we became the DAO. On Friday, June 17th, 2017, programmers experienced real consequences, right? Existential consequences. We lost over $50 million worth of ETH and destroyed a $150 million organization. Just like that. Those are consequences. So let's put it in perspective, right? When you are writing the next Facebook killer UI and it crashes at odd times because users do weird things occasionally, it's okay to reload your browser and move on, right? That's not the end of the world. However, when 3 innocuous lines of code in the wrong order wipe away millions of dollars of wealth and utterly destroy your organization, perhaps you have chosen the wrong architectural model upon which to build your future. And this is not an exaggeration. You all know what I'm talking about. I call this Dijkstra's revenge, right? We have to hold ourselves to a higher standard. We take the position that not only programmers' responsibility to produce a correct program, but also to demonstrate its correctness in a convincing manner. That changes what our role as programmers are, and it changes the tools that we should be using. So, the DAO disaster, right? How do airplanes crash, and why does wrong crypto destroy wealth? Well, they all have similar characteristics. Rarely ever caused by catastrophic failures in key systems. The wings don't just fall off. Almost always the result of multiple small innocuous failures that only manifest themselves in rare edge conditions. This is why planes fall out of the sky. This is why code breaks. And it's always caused by things that grow geometrically as the complexity that drives them increases linearly. This is a very well-known phenomenon, and something that we encounter all the time. As our complexity of our contracts goes up linearly, the danger and the outcome of what needs to be tested or what could possibly happen goes geometrically, right? And these are kind of things that humans cannot see. We have to build technology that prevents this stuff from happening in the first place. Okay. So let's look here real quick. This is the actual DAO code that was the actual failure of the DAO. And it's the split DAO. So this is when you were want to pull your money out, when you were going to pull your funds out of the DAO was where this occurred. You got this line of code here that's withdrawal reward for the person who called it. This is the Solidity code. This calls a function that actually doesn't get to the next line. The next line that matters is updating the balance for that person, right? So if it never reaches that line and instead it goes back up to here at the beginning of the function, it just recursively calls and just keeps on withdrawing money from the contract, not even money that is limited by the amount of money that the guy had in the DAO. It drained the whole DAO as much as the gas per call would support it. If you would have put that second line of code above the first line, the hack wouldn't have happened. Now, how are you supposed to detect that? That's not something that a human's going to look at, right? That was a reentrancy error, right? So there's various issues that cause these things to occur, and what could possibly inspire such obviously defective model, right? What does the word ledger mean? When we do accounting systems, we have ledgers. Ledgers have to balance. Why is this not an atomic intrinsic operation of our languages, of our blockchains, right? So I'm looking at you, JavaScript and Solidity folks. So Solidity, what is Solidity? What's the definition of Solidity? Well, I say it is a programming language designed to prove that Ben Scherrey was wrong when he proclaimed in 1998 that a greater abomination than JavaScript would never again gain widespread adoption. I actually said this at the time because I really saw how awful a language JavaScript was for what we were trying to build, which was secure systems that we were going to do financial transactions on. And this is actually the Solidity Wikipedia. And sure enough, Cornell University researchers stated that Solidity was partially to blame for the DAO hack in 2016. It was, and Solidity, designed by Gavin Wood, is designed around ECMAScript, which is the formalization of JavaScript. So JavaScript coming into our ecosystem is one of the root causes of a lot of the problems that we've been seeing. And the reason why they did it that way is because they wanted a language that would be accessible to young, inexperienced programmers. But should young, inexperienced programmers be writing contracts that control billions of dollars of wealth, other people's wealth, and have no repercussions for it? I think that's wrong. How do we fix this, right? Programs must be written for people to read and only incidentally for machines to execute. Whoops, went too far. And then my favorite quote, debugging. Debugging is twice as hard as writing the code in the first place. Everyone should memorize this. Therefore, if you write code that's as clever as you can possibly write it, you are by definition not competent enough to debug it. As Brian Kernighan said that. We need to really lock this in. We have to control complexity. We have to keep things simple. So Vyper, first commit by Vitalik on November 16th. So we just had our 6th birthday. Happy birthday. After abandoning a new language called Serpent, which is a low-level Pythonic assembly language. I personally adopted Vyper. I discovered it in late 2017. And I encountered great guys, Charles Cooper, Brian Eisenbach, Big Tech Sucks, several other guys that are still in the Vyper forum today. Have just been fantastic community owners. I actually did some minor upgrades to the compiler itself with my team. We introduced 2 code generation improvements that turned a simple contract from 54K in size to 1,644 bytes. So there were some code generation problems with the Vyper compiler in early days. In fact, the Ethereum Foundation practically ran a coup against the Vyper team by funding a team to create a Rust implementation of Vyper that fortunately ultimately failed. So Vyper is written in Python, and then it uses this low-level language LLL that's now turned into its own intermediate representation. It's kind of a Lisp-like language to generate the code itself. Having Rust implement Python and then implement EVM just seemed kind of strange to me, and they weren't as committed to the project. Unfortunately, these guys survived. So that language turned into something called FE, as in iron for Rust, which targets EVM and WASM. And they've now since brought back curly braces. And what's interesting is it still resides as an Ethereum organization on GitHub, whereas the Vyper project is completely an independent project now. So I thought that's kind of an interesting bit of history. Also, when the 1155 standard came out, and I've commented on other things, but I really drove and pushed through Vyper interoperability on the specification for that, because all the ERCs, all the EIPs are written to be basically implemented in Solidity. So the specifications are for that. So things like dynamic arrays and stuff being put in the specs were bad news back then. So I managed to make sure that the ERC 1155 standard could be implemented in Vyper, and I think we implemented the first one of them. So cool aspects of Vyper. You got safe dynamic arrays and domain types, no over and underflows. You don't have short address errors. You don't have to use nasty, huge gas costly libraries required just to add 2 numbers together. Now, Solidity has fixed some of these things, but only just recently, and they still can represent things incorrectly. You get bounded non-determinism. This means that there is an absolute limit as to how far the computation of your contract will go. These kind of determinate limitations, it's actually a limitation by the compiler and the language, forces you to think through the design of your contract better and make it more formally correct. That's a very important thing. Is my time really up? I can't hear anybody. Is my time up, or do I have more time to go?
Oh, no, you're good.
Okay. All right. Also, we get Python virtual environments, right? You don't have to deal with your JavaScript conflict hell with whatever the build system that JavaScript is using today. Maybe a little occasionally pip will have a conflict, but nothing like what we have in JavaScript Node.js world. You got BOA, Titano BOA, that people have talked about earlier, and that's Charles Cooper's project. This is the ultimate Ethereum REPL, and it's so great. We actually, back in 2019, forked the PyEVM to allow us to do a little bit of exploration of the state of the blockchain while our contract code was running. You had to manually move mine your next block and stuff. But it was hard to keep that maintained and going. And what they're doing with BOA is just really, really amazing. Ape is another fantastic tool made mostly by the old Brownie guys. It's Brownie done right with plugins. They just orchestrated the thing to make it more composable. Again, better improved architecture. And it's Python, right? Python's great. You get readable, auditable code with no surprises. And I'll show you what I'm talking about that, right? You can get stakeholders who understand the specification of your code actually understand the code as well. So let's take a look at how we design a piece of a contract. So we have a specification. So this is for a function called submit strategy, which is for a project for a group called Dynamo DeFi that's going to be deploying this and integrating with Balancer. And we're writing this in Vyper for them. So they actually picked us out because they want to do this in Vyper. So we've got this function where we submit a strategy to their financial instrument. We've got a little bit of formal specs that people will be able to understand who are financial advisors as to what this pertains to. And this is all just a markdown language with mermaid diagrams. So here you can't read it here, but I'm zoomed out to show you this is the entire specification of this function, right? So it's got 3 actors, one of which being the Ethereum network itself. And we'll zoom in as to what this looks like. So for the governance contract, we have a set of preconditions. And on the left-hand side, it's pretty much, Python, what it is. And we just kind of explain what each thing is. And then in each block, we give a little human text about what it is it's supposed to do. But the line under it that implements it is the actual Vyper code. And it's pretty much one-to-one like that. And so you can show this to a stakeholder who's not a programmer, and they can look over this and they can help determine whether your code is correct or not. You can't do that with Solidity. So the difference between a high-level language and a low-level language is that a low-level language makes you have to consider and think about all kinds of things that aren't relevant to the domain of your problem. And when you have that, that's distracting. That's where errors get introduced. What's the future for Vyper? Well, this is potential future, right? These things aren't locked in. Vyper's possibly going to be introducing modules, which is going to be a way to import a piece of code or specification, but not have to follow all the inheritance hell that you have to when you're going through a big chunk of Solidity code. So this would be a great way to modularize code, but still make it very easy to understand and audit. The other thing now, back in 2019, Vyper wasn't as efficient gas-wise, and it had other issues and stuff. Now it's competitive and better than Solidity in terms of gas generally. So now it's time to displace Solidity, right? How do we do that? Well, we need to build some interoperability tools to make it easier to take like deployed Solidity code with deployed Solidity interfaces, parse those, and make those something that Vyper can call very easily, so that organizations who have large Solidity investments, vendors who have that, they can graduate to Vyper without having to rewrite all their old code. That's going to be a very important thing, I think.
Then we have to wrap up soon.
Okay, we're almost done. We must improve tooling. One thing that's broken with Vyper is a couple of partial versions back, code coverage is broken. Broken everywhere. It's broken on Brownie. It's broken on everything. And we really, really must have code coverage back working again. It does not work with the latest versions of Vyper. Yeah. So we need provably correct algorithms and code because we need to be able to do contracts that are 2 or 3 orders of magnitude more complex. And yeah, I think that's really it. I'm happy to take any questions, comments, or arguments.
I'm afraid I think we will be kicked out by the system soon. Nevertheless, we have posted the face-to-face link on Discord as well, so you can catch Ben in person and ask him. I've already seen a question about tooling or documentation that would be useful for people looking to get into Vyper. So I think that would be probably a great one to talk about. And yeah, thank you so much for speaking and sharing your experience. And I think that's definitely an opinion that needs to be heard more.
All right. Well, I'll be in the face-to-face. Thanks.
Thank you very much.